In this video, I am going to explain broadcast routing in computer networks. The definition of that broadcast routing is the process of sending multiple packets, not multiple packet, the process of sending a packet to all destinations simultaneously. The process of sending a packet to all destinations simultaneously. The process of sending a packet to all destinations simultaneously is called as a broadcast routing. Different ways of implementing the broadcast routing are different ways. Different ways of implementing broadcasting. First one, sender maintains multiple destination addresses and send packets to each of them simultaneously. Sender maintains multiple destination addresses, and sends packets to each of them simultaneously. The process of sending a packet to all destinations simultaneously is called as broadcast routing. All destinations, it is very important. Different ways of implementing broadcasting are: first technique is sender itself maintains multiple destination addresses and send packets to each of them simultaneously. This one is source. These are the destinations. Destinations. This destination is not active. This destination is active. These two are not active. This one is active. The source maintains multiple destination addresses and send packets to each of them simultaneously. These are the packets are sending in this fashion, like that. In this fashion. Next one is this fashion. Like finally reach to destination. This is called as a broadcasting. Second technique is flooding. When this is the router, whenever the router receives a packet that is to be broadcasted, it simply flushes these packets out of all the interfaces. When router receives a packet that is to be broadcasted, broadcasted means this is the router. This is the router receives packets from the source The router broadcasts its packets to the neighbor nodes in this way and in this way. That is called as flooding. When a router receives a packet that is to be broadcasted, it is simply floods these packets. Flood these packets out of our databases. This is called as flooding. The router identifies the outgoing lines. That particular router places the packets on the outgoing line, except that router receives the packets from the corresponding line. That is called as flooding. Third important technique is, third one is multi-destination routing. Multi-destination in the first method, the source itself contains multiple destination addresses. In the second case, flooding, every router identifies outgoing lines, places the incoming packets on the outgoing lines. That is called as flooding. In the third method, multi-destination routing. Multi-destination routing means each packet contains either a list of destinations. Each packet, not source. Each packet contains either a list of destinations or a bitmap indicating the desired destination. Each packet contains either list of destinations or a bitmap indicating the desired destinations. Suppose when a packet arrives at a router, this is the router. When a packet, this is the packet. When a packet arrives at a router, the router checks all the destinations to determine the set of opposite lines. Destinations and determine the set of opposite lines that will be needed to carry these packets. When a router, when a packet arrives at a router, the router checks all the destinations. The router checks all the destinations to determine the set of opposite lines. That will be needed. Generally, in the multi-destination routing method, in this case, the router created. In this case, the router creates multiple copies of. The router creates multiple copies of single data packet with the different destinations. with different destination addresses. These are the three methods explanation. The packets itself contains multiple destination addresses. The router creates multiple copies of single data packet with different destination addresses. This is the multi-destination routing. Multi-destination routing. Next, fourth one is reverse path forward. The fourth method is reverse path forward mechanism. This is the A figure indicates subnet or a network consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. A, B, C, D, E, F, G, H, I, J, K, L, K, L, M, and N. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And M, N, O, also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 rotors. Calculate edges. So calculate the number of edges in this graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The number of edges in that graph are 19. B graph represents subgraph of that A graph. Subgraph of the A graph. The number of edges in that B graph, that is called as a sync tree. That is called as a sync tree. A sync tree consists of the number of edges present in the sync tree or a subgraph of the main graph are number of rotors minus 1 or number of nodes minus 1. That is equal to where n is the 15 nodes are there. 15 minus 1, that is equal to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 nodes. This is the sync tree. Sync tree definition is the spanning tree for a graph is sync tree. Sometimes it is also called as a spanning tree. Spanning tree or sync tree for a graph is a subgraph that includes every vertex. That includes every vertex. Every vertex means up to A to O. That spanning tree is also included every vertex of the original graph. Spanning tree for n capital N vertices must contains n minus 1 edges. This is the main graph. This main graph consists of. This is the main graph. This main graph consists of some subgraphs. 1. 2. Three. 4. Five. The main graph consists of 5 subgraphs. 5 subgraphs. This one is 1. Green color 2, 3, 4, and 5. Generally 5 graphs are there. The total number of edges, in the sync tree and a spanning tree are n-1, where n is called as number of vertices in the main graph. 15 minus 1 is equal to 14. Here consider first one. This one is the first one. In that first one, remove one edge. This one is remove this edge. Remove this edge. Therefore, the graph consists of E A F I and H. Remove this. Remove this link. This is the first graph consists of rotors A, F, I, H, and E. This one is first one. A spanning tree is a subtree of that main graph. Includes all the nodes. Remove this H. Remove this H. E and H is removed. Therefore, this subgraph consists of all the nodes within the subgraph. Connect all the nodes. E to A to F, F to I to H. Okay. This one, first one completed. Coming to second one. In the second graph, this is the second loop. This is the second loop. HK link is removed. The spanning tree does not contain any loops. One more important point is the number of branches in the spanning tree are n-1, where capital N is called as number of vertices in the main graph. Another important point here is that the spanning tree does not contain any loops. The spanning tree does not contain any loops. Okay, remove this one. Therefore, in this one, in the subgraph consists of rotors H, I, N, M, K. Whenever this link is removed, HK link is removed. Therefore, it forms the graph is like this. It connects all these rotors H, I, N, M, K, L. This is the for second loop, second subgraph. Coming to third one. See the third one. This is the third one. In the third one, the nodes included in the third loop are L, K, M, N, I, F, C, D. This is the loop, third loop. The spanning tree does not contain any loop. If you broken that any one edge here, LBH is removed. LBH is removed. That is good. LBH is removed. But all the nodes are connected. B to C, C to D, D to F, F to I to N, N to M, M to K, K to L. All the nodes are connected. All the nodes are connected. Third loop is also completed. Next, fourth loop. In that fourth loop, this is the fourth one, I, J, O, N. We remove either IJ or JO or ON, whatever it may be. ON link is removed here. Okay. This loop consists of I, J, O, N. I, J, O, G. I, N. All the nodes are connected. Only ON link is removed. Next, one more loop here is this one. This one. Here, DZ link is removed. DZ link is removed. In that loop, IFDGJI, IFD, IGJ, IJG. All are connected. In that fashion, had to create a spanning tree or a subgraph of that subgraph or sync tree of the main graph. Sync tree of the main graph. It includes all the vertices from A to O. In this spanning tree, this is the spanning tree, includes all the vertices from A to O. This is the tree built by a reverse path forward. Consider I rotor node. This is the I rotor. From the I rotor, have to examine multi broadcasting means this I rotor send same packet to similar packet to all the destinations. All the destinations in the graph is called as a broadcasting. This is the I node. For that I node, the neighbor nodes are H, N, F, J. This one is I, F, H, J, N. These are the neighbor nodes of I. These are the neighbor nodes of I. These nodes are on the spanning tree or sync tree. These nodes are connected. Therefore, these nodes are circle. These nodes are circle. Next, from F to this one is F. This is the first half. This one is first half. From F to A to E. F to A to E. All are nodes which are connected in the spanning tree. In the original graph, E to H is also there. Therefore, that is the reason that connection is removed. Therefore, H is not circle. Therefore, H is not circle. From F to D, D to C, C to B. F to D, D to C, C to B. B to L connection is there in the original graph, not there in the sync tree. That is the reason L is not circle. L is not circle. One more connection is there from D to Z in the main graph. In the spanning tree, D to G connection is not there. Therefore, G is not circle. G is not a circle. This one is H. This one is H. In that H, there is no connectivity to E and K in the spanning tree, but in the main tree, E and K connections are there. That is the reason E and K is not circle. Not valid rotors. E and K connection is not there. Next one, N. N means MKL. MKL, all are valid. That is, these rotors are circle. And B is there. B is there. In the main graph, L to B connection is there. L to B connection in the spanning tree. L to B connection is not removed. Therefore, B is placed here. In K to L, and the L to H, K to H. This is the K to H is not there in the main graph. In the spanning graph, K to H connection is there in the main graph. That is the reason H is not circle. In that fashion, you have to develop tree built by reverse path forward. In that graph, circle rotors are valid ones. Uncircled rotors are not valid ones. Not desired paths to reach from H to E, H to K. In another way, that information is reached to E node and K node. This is the half 1. This is the half 2. One is half 2. Next one, this one is half 2. This one is half 3. One is half 4. Finally, hub counts from original node I to all the destinations. From original node I to all the destinations are remaining nodes are A, B, C, D, F, G, H, and so on. These are the indications. Next one is count the number of preferred path packets. Total count the total number of preferred packets. This one is a preferred path. This one is preferred path. But preferred path 1, 2, 3. This is not a preferred path. 4. This is not a preferred path. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 packets are total packets are by considering this span, by considering this primary, by considering this main one, by considering that main one, by considering this main one, count the total number of duplicate packets. Total number of duplicate packets are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. By considering this original graph, total number of similar packets are needed is 24. By considering spanning tree, total number of packets are needed is 14. That is the main advantage of this one, is eliminate the more duplicate packets which are threaded into the network. This is the tree built by reverse path forward. With this 4 techniques of the broadcasting routing mechanism is